Dear students, good morning. Last class we discussed about electrochemical instruments for analyzing like silica, pH, sodium. So all these can be known with some suitable diagram, right? So and today we see uh, the important concepts like spectrometer or spectroscopy. So before going to know that spectroscopy, you have to know the basic principle. Uh, it will be applicable in the spectroscopy, right? And so it's nothing but Beer-Lamberts law. Beer-Lamberts law. So here there are two persons are available in this Beer and Lamberts. So combiningly it becomes like Beer-Lamberts law. But what is Beer's law or Lambert's law? So before going to know this Beer-Lambert's law, first of all, you take any tablet or medicine. Our aim is in the medicine, what is the drug present and what is the concentration of the drug? We have to know the two concepts. So how do you know these two concepts? Two parameters like drug present in the medicine and the concentration of the drug. How do you know it? So the simple method is volumetric analysis. The chemistry people well known about this volumetric analysis, doing something, adding that chemical. Ultimately, by weighting it, they can be known that this is the, I mean, there is a drug available and concentration of the drug. So there is a long procedure is available for knowing the drug present in the medicine and concentration. That is called volumetric analysis. But it is not suitable for all the all the chemicals. It is not suitable procedure. So what can you do? The the remedy for this is spectroscopy. So by applying some electromagnetic wave on the medicine, such that is available supported in the circuit, we can redrive the drug present as well as the concentration of the drug. So it is done with the help of electromagnetic wave, right? So, uh, so based on this electromagnetic wave, and we have Beers-Lamberts law. Beers-Lamberts law. So in this, what happens? Take any sample, in the container, solution in the container. For this solution, you apply some electromagnetic wave, right? So initially the electromagnetic wave, nothing but light, say, nothing but light. Light has initial intensity, say for example, high intensity generally. When it is passing through the solution, there are three concepts are going to happen. Three concepts. One is the light when it is passing through the solution, the light will be absorbed. Light will be absorbed. That is first case. Second case, when the light is passing through the solution, and some of the light is absorbed and some of the light is emitted. I mean, I'm sorry, that is transmitted. That is transmitted. That is called transmitted light. Here absorbed light and transmitted light. And remember, we have two more parameters here. When the light will fall on the sample container, because the container is a rough surface, for example, any container having rough surface, when the initial light will fall on the surface of the container, if it is rough surface, some of the light is reflected, some of the light is reflected. It's not a problem, we can overcome it. How can you overcome the reflected light? The reflected light can be simply overcome by placing a smooth walls for the container. If you place a smooth walls for the container than this rough surface, we can maximum we can overcome the reflections. Okay? Clean. Then one more is when the light will fall in the sample, as you know that absorption is happening and transmittance, light is transmitted to outside. That is also happening. But one thing, the third one is when the light passing through the solution, that is scattered into the outside world. Why? Why the light is scattered? The reason is if a solution having solution or sample is completely dissolved in the solution, the sample to be measured, it is completely dissolved, no scattering light is happening. No scattering, the scattering is zero. But what happens, sometimes in a solution, the sample which is to be analyzed, if it is in the solid state, it is the solid particles. So when the light will fall on the solid particles, that is scattered to the outside. So how can you overcome this scattered light? Scattered light? Very simple. You try to dissolve the sample in a solution completely. The sample to be analyzed, you dissolve completely. There should be no solid particles in the solution. Then you can avoid scattering of the light. So we can overcome two parameters. First is reflections is overcome by placing a smooth and polished surface of the container. We can overcome it. Second one is scatter reflections can be overcome by complete dissolve dilution of the sample in the solution. We can overcome the two minor disadvantages. But when the initial light will fall on the solution, absorbed, some of the light is absorbed, that is one, and some of the light is transmitted. Transmitted. Right? But the point is, what is the initial intensity of the light? So for example, is I naught. Initial intensity is I naught. And what is the light transmitted after the sample, after the container? What the light is transmitted? That is called say IT. IT. T refers to transmitted intensity. I naught refers to initial intensity. Right? You know that in between absorption is happening. Some of the light is absorbed. Right? We want to know that how much absorption is happening in the sample. We want to know it. So that we are going to study about the Beers-Lamberts law. So here two things going to be happen. Two things going to be happen. So the Beers law states that the intensity of a beam of monochromatic light, remember once again, the intensity of beam of monochromatic light decreases exponentially with increase in concentration of the absorbing substance. What it means? The Beers law states that if any solution, the solution nothing but sample, when the light falls through the sample, it is absorbed. The, the concentration, if the concentration is high, absorbance is high. The solution concentration is high, say maximum light is absorbed by the solution. If concentration is low, less absorption is going to be high. That is the meaning of it. See once again, the intensity of the beam of monochromatic light decreases exponentially with increasing concentration of the absorbing substance. So if concentration is high, intensity decreases. Definitely. Because why it is intensity decreases? Maximum absorption is happening in the sample. So how much light in the transmitted very less light. Less light is transmitted. That is called decrease. So it can be mathematically written I equals to I naught into e power minus kc. I equals to I naught into e power minus kc. Kc. What is I refers to? I refers to IT. IT means transmitted light. That transmitted light is equals to I naught initial intensity. Initial intensity of the light. We are going to send through sample. That's the initial intensity. E is an exponential. C nothing but concentration of the sample. Concentration of the sample. K is a factor. It's a factor depends upon the solution. Right? So the transmitted light intensity is equal to initial intensity into e power minus kc concentration. So the intensity is proportional to exponentially decreases of the constant of the solution. That is the Beers law. This it is very simple to understand. Beers law states that when the light will fall on the sample, it is absorbed in the sample and some of the light is transmitted. That intensity of the transmitted light, how it relates to the absorbance means if light intensity is high, less absorption, less concentration. If light intensity is low, light intensity is high, at the output side, high means less absorption, less concentration. If it is low means high absorption, high concentration in the sample. That is a Beers-Lamberts state, the effect of concentration. So, in very simple, if the sample concentration is high, absorption, maximum light is absorbed, so less light intensity is going to out, transmitted. That is the Beers law. Okay. Next, what is Lambert's law? Lambert's law. So Lambert's law says that the effect of cell path length. Cell path length. Cell path length means depends upon geometry of the container. Geometry of the container. So what is the size of the container and how much sample we are going to take into it? How much sample is going to be taken? Path length refers to if the size of the sample is like this, or size of the sample may be like this. Container, or maybe like this. So when the light will fall, and it is traveled through the sample in the length of this much, or the length of this much, length of this much. So that's called path length. Path length. So see the statement. When the beam of light is allowed to pass through a transparent medium, the rate of decrease of intensity is the thickness of the medium. Thickness of the medium is directly proportional to intensity of the light. Intensity of the light. So, if the light travels maximum path length, intensity decreases. Intensity decreases. Less path length, intensity increases. That is the meaning of it. So, what happens when a beam of light is allowed to pass through a transparent medium? The rate of decrease of intensity is the thickness of the medium. Thickness of the medium is directly proportional to intensity of the light. It can be written mathematically. I equals to I naught into e power minus kt. I equals to I naught into e power minus kt. T refers to transmitted light. So I equals to intensity of the transmitted light. Can we write I naught into e power minus k and t. So what happens here? What happens here? If the size of the container or thickness of the medium, transmitted medium, nothing but solution. If it is going to be changed, less absorption, less absorption, less path length, less path length. Partiality is less absorption. So so um, so the thickness is very less. Thickness is very less. So you may get maximum light in the output side. If it is high path length, I mean path length is high and the medium, I mean the thickness is very high, the medium, so you will get very less light or dense. That's what happening in the case of Lambert's law. Combine these two, combine these two, the Beers-Lambert's law. A combination of the two laws, known jointly as Beers-Lambert's law, defines the relationship between absorption and transmittance. Absorbance and transmittance. Absorption is happening within the sample container. Transmittance is happening out of the out of the container. Transmitted light. So the relation between absorption and transmittance is, it states that the concentration of the substance in a solution is directly proportional to absorption A. So A can be write absorption rate is equal to epsilon Cv. Epsilon is a molar absorbability. Molar absorbability. A is the absorption, no units. So C is the molar concentration. B is the partner. B is the partner. So Beers-Lamberts law states that the absorbance is proportional to concentration. Absorbance proportional to partner. That means what it says, if concentration is of the solution is high, absorbance is high, maximum light is absorbed. If path length is high, that is the geometric shape of the container and thickness of the solution. If it is high, absorption is high, maximum light is absorbed. That's the meaning of this. Beers-Lamberts law. Okay. Oh, next class we will see spectroscopy. Right? Now I am going to stop here. Next class we will see spectroscopy. If you have any doubts, you can ask me.